Hello everyone, this is Byomkesh. I'm gonna be the trainer for today's module on CNN, the webinar which we are conducting on behalf of ExcelR. Let me first very quickly introduce ExcelR. Yeah, so we started around 10 years back, and this ExcelR got started by two of basically our founders. They are from IIT and IIM, started by Ram Tava and Varni. Till date, as I said, we are in this training field from last 10 years. And till date, we have trained around 130K participants globally. And we are into USA, Malaysia, UK, and Southeast Asia. But then when we started training in artificial intelligence and data science around 5 or 6 years back, and till date, we have successfully trained around 20,000 data scientists globally. Okay. Yeah. Now, very quickly, I'll introduce myself. I'm Byomkesh. I completed my master's in technology from IIIT Bangalore in data science and artificial intelligence. I have around 5+ years of experience in this domain, and till date, I have applied AI and you can say machine learning skills into multiple domains uh, like retail, healthcare, recruitment, and finance domain, to name a few. Uh, so I'm going to be taking this webinar on CNN, where very quickly we'll try to understand what is computer vision, then what exactly are the different applications of computer vision, then the neural networks and how exactly that neural network, all the algorithms which we discuss or we learn under artificial intelligence are motivated by our human neurons or the brains, and then we'll discuss few concepts of CNN, the architecture, and we'll move into an application of CNN. Okay. Before I proceed, I will request all of you to basically subscribe to our channel on YouTube, which is ExcelR, in order to basically be updated with whatever interesting webinar we do on a regular basis. And at the same time, we're going to have multiple follow-up series on these interesting topics. So it will be very easy for you. Once you subscribe, we are going to be notified on time the moment we propose or basically we take any webinar. Yeah. So let's start. Yeah. So today's webinar is on CNN, known as convolutional neural network. So very briefly, first, let me talk about this field of neural network. When we talk about machine learning or artificial intelligence, what exactly is an artificial intelligence? We say that artificial intelligence is a wing of computer science where we try to mimic the human brain. Okay. And underneath artificial intelligence, we have multiple algorithms. Broadly, we can classify them into three buckets: supervised, unsupervised, and reinforcement learning. Basically, in supervised bucket, we have one algorithm called neural network. The main motivation behind the name neural network is basically comes from the way our human brain works. All the algorithm which we discuss under deep learning are exactly inspired, or you can say motivated by the way our human brain works. And in our brain, if we try to understand, we have millions of neurons. So every action we perform, it basically we have multiple neurons in our brain which in a way coordinate with themselves, and then we perform any action, right? So whatever action we perform, it's like if you walk, if you feel something, if you see something, or if you taste something, it's all is happening because of the multiple neurons which are interacting among themselves in order to perform a certain specific task. And all the neural network algorithm which we discuss are exactly inspired or motivated by human neurons, and that's the reason, or you can say motivation behind the name neural networks, right? Now what happens, in subsequent slide I'll try to explain very quickly what exactly is a neural network and what is the difference between human neurons and you can say machine learning neurons, right? And when we try to understand how deep learning is different or similar from neural network. In simple term, if we need to explain what exactly is a deep learning, so first we'll have to understand that deep learning is nothing but deep neural network. Okay, so in any normal neural network, we have few neurons and very few layers, right? But then in a deep neural network, what happens is you're going to have multiple layers and at the same time multiple neurons in each layer. Okay, so that is the main you can say difference between neural network and deep neural network. And deep neural network is something which is called as deep learning. Okay, so as I have said, agenda for this webinar is that we'll try to understand what exactly is computer vision, what are the different applications of computer vision which we see around us, and then the main algorithm which contributes a lot when it comes to any computer vision application is CNN. So we'll try to understand the different, you can say AI specific jargons which are in a way contribute to CNN. Okay, yeah. So let's start. First of all, let me explain what exactly is our vision. Okay, vision is something the moment we try to represent any entity or any event. Okay, pictorially, that's what we call as vision or image, right? And especially when it comes to the wing of artificial intelligence, the wing of machine learning or artificial intelligence, where we deal with image or video data, that wing is called as computer vision. Like if you try to understand in this entire world, whatever data we generate, we can classify them into four buckets: text, audio, video, and image, right? So text and audio is something which comes under NLP, which is also known as natural language processing. And then computer vision is something where we deal with image and video data, right? So now what happens? There are multiple applications which we see around us, which are in a way, which are AI powered, or you can say computer vision applications, right? Right now on your screen, if you see the slide, right, it's going to be very difficult for any normal human to identify if we have one animal or what exactly is in this image, right? But then it's not going to be that difficult for a machine. Okay, because of the intelligent or the smart architecture we have around multiple neural networks, right? Like if you'll try to notice, it's going to be very difficult for you to identify what exactly we have in this image, right? But then the moment I click on this next image, you can clearly see that we have a cow in this image, right? So what happens is sometime we have applications where human eye perform better than machine, but then at the same time there are applications where a normal AI algorithm, or you can say vision algorithm, can perform far better than a human eye, normal human eye, right? Because as a human we have our own strength and limitation, right? Similarly, when I move to the next slide, if you see in this image, there are so many things which are happening, right? So what exactly we try to infer after applying any computer vision application to, let's say, these kind of image, or what are the different kind of information which we can extract out of this image, right? So you have verification, like basically you can use an AI model to verify if you have uh, an object like a lamp over there in this image or not, right? Similarly, we can have a detection problem, that if we have people in this image or not, right? Similarly, we can have pose estimation, like what are the different activities getting performed by all these people in this image, right? Then we have object categorization, like if you see in this one image, we have multiple objects like table lamp, you have umbrella, you have flags, we have, we can say multiple yeah, people, and then we have trolley, different kind of objects, right? Then scene categorization means what, like in some way you can say that okay, this belongs to a hill station, right? Because we see some hills in the background, right? Then if you go further deep, and then what are the different attributes, like what is the color of the lamp, right? Similarly, how many people are there in this image? Then what are the different kind of objects which are present in this image, right? So these are the different kind of you can say vision model or vision uh, like AI powered application which we can deploy on this single image in order to extract multiple informations, right? Yeah. So now there are multiple computer vision applications which we see around us, be it image captioning, object detection, pose detection, video surveillance, activity detection, image segmentation, image diagnosis, like what happens in healthcare, right? These days you will see that there are multiple research organizations which are investing a lot in healthcare domain in order to identify the different disease from x-ray or different ultrasounds, right? So that's called image diagnosis. Similarly, image search, on any retail platform now, you will see on search box which is powered by image, where you can just drag and drop your image and they will find the similar product. At the same time, we all use, at least most of us, we use Pinterest, right? So on Pinterest also we have this image search, right, where you just need to create a box around the interest of object of interest, and Pinterest will try to find the similar object in their database, right? So these are the different applications when we talk about object detection, right? Again, we have multiple use case around object detection. A single object detection algorithm on image or video can be very helpful when it comes to the trend analysis, when it comes to the video surveillance, or when it comes to any traffic analysis also, right? So these are the different applications of computer vision where we try to deal with, you can say, uh, video or image data. Now, the algorithm, which in a way helps us in doing all these activities, is a neural network. Now, underneath neural network, we have multiple architectures, right? So we have CNN architecture, we have RNN architecture, right? Similarly, we have LSTM architecture. So CNN is the main algorithm which are basically which empowers all these different, you can say, applications of computer vision, right? So the full form of CNN is convolutional neural network. Okay. So today in this seminar, basically we're going to talk about that. Okay. Now, if we try to understand, on your screen right now, you can see a very basic neural network architecture, right? So what happens is, if you see, we call, as I said, when it comes to human brain, we have millions of neurons, right? Similarly, in this neural network, this is what is called as neuron. Okay. So how many neurons we have in this? You can say 4, 8, 11, 15, 19, 22, right? So in this particular architecture, we have 22 neurons, right? Now what happens is, this is something which is called as layer, right? So how many layers we have in this neural network architecture? In total, 6 layers, right? So this entire thing is going to be called as layers. Now, all these neurons are basically going to be connected to each and every neuron. Okay, there are certain architecture where we don't connect all the neurons. Okay, but then that's like too much detail of CNN architecture. But then as of now, we are going to assume that all these neurons are basically connected to each and every neuron in the next or immediate layer. You can say like this. Right? So the single arrow basically specify that all the neurons in the early layer is connected to all the neurons in the next immediate layer, right? Okay. So as I said, this is neuron. This we call as layer. So in total, we have 6 layers in this neural network architecture, and then this is what is called as your input. Okay. So for this webinar, our input is gonna be image. Okay, and this is what is gonna be your output. Okay, let me give you an example. Let's say if we are trying to work on an animal classifier, okay, and we wanna basically build a cat versus dog versus other animal, right? So any image is gonna be your input, you can say, and let's say in this image we have cat, and your output is gonna be cat, dog, and other, but the maximum probability is going to be for cat, like 0.8, 0.1, 0.1, right? So this is how any normal neural network looks like. Now, as you if the moment we try to draw similarity between this architecture with the way our human brain works, so what happens is, as I said earlier, that whatever activity we perform, there are millions of neurons in our brain, and basically multiple neurons participate in any activity, right? So even here you can see that we have multiple neurons which are connected in a specific way, and in order to basically classify which is the activity which we are going to do over here, they are going to, like you can say that this is nothing but this layer identify the color, okay, this layer identify the shape, okay, and this layer is, let's say, trying to learn how to identify the eyes, right? And this layer you can say is gonna learn how to identify the tail, right? So this is how different layer basically are gonna be. We are gonna train a model. The moment we train any model, this is what we can actually interpret that these layers are trying to learn. Okay, so that's about a simple neural network, right? So let me go to the next slide. So when it comes to CNN architecture, right? First, we'll have to understand few basic concepts. Okay, there are filters, strides, and pooling. Okay, which in a way contributes to any CNN architecture. Okay, so now let's try to understand what exactly is a filter. The moment we talk about CNN, yeah. So if you see, this is one matrix. Let's call this an image, right? So as you know that when it comes to image, there are multiple color spaces. Let's say this is your image. So you can basically classify them into a matrix, which is nothing but the pixel, right? So let's say if this image is 5 and 5. So we are going to have 5 cross 5 matrix, right? And how we represent any image, there are multiple color spaces around us, but then normally we all would have heard a lot about RGB color space, where R means red, G means green, and B means blue, right? So what's going to happen is, in order to represent any image in a mathematical way, we need basically n cross m cross 3 matrix, where n is going to be your length, m is going to be your width, and then 3 is going to be the depth of color space. So let's say if we use RGB color space and we have an image which is of size 5 cross 5, so how many what is going to be our matrix shape? That's going to be 5 cross 5 into 3, right? But then there is one different color space which is known as grayscale. Okay, now what is this grayscale? So nothing but a black and white picture, right? So in black and white picture, we either represent everything as 0 or 1, you can say, which is 255, right? So 0 is nothing but your, you can say, black color, and 255 is nothing but your white color, right? So in this we need like the depth of color space is going to be only one. Why? Because either any pixel is going to be white, or any pixel is going to be, or it's going to be black, right? So if you have an image of 5 cross 5, and if we have a color scale, right, which is grayscale, in that case the matrix size is going to be 5 cross 5 cross 1. So we can also represent this as 5 cross 5. Okay, so now let's say this is one image, okay, and what are these are nothing but the individual pixel values, right? So the concept which I'm trying to explain right now is called as filters, right? So what is the size of this image? Nothing but we can say 6 cross 6. Okay, so what is filter or what is convolution? Okay, so convolution, we say mathematically, is a process where we apply one function on a second function in order to get a third function. Okay, so what is convolution? Let me repeat again. Convolution is a process where we apply one function on a second function in order to get some third function, right? So if you see, first let's try to understand, even before without understanding the filter, why this process is called convolution. Because if you see, let's say this is your first function, this is our second function. So what we are going to do is we are going to apply this function on this particular entity, and we'll get this. Okay, the third function. So that's the reason this operation is known as, or you can say the architecture is known as convolutional neural network. Why? Because neural network, because we are going to have the neurons and the different layers, and all these layers are going to be connected. And why convolution? Because that's how we extract the features. Okay, now let me explain what exactly this operation is. This particular entity is called as filter. Okay, so let's see how exactly we apply this filter. So what's a filter? As I said, this is something, the convolution process is where we apply one function on a second function in order to get the third function, right? So this is what is called as filter, or you can say as mask or kernel, right? So let's see how we apply these filters on the original image, right? So let's say this is 6 cross 6. What is the size of this one? 3 cross 3. So the way we apply any filter is that first of all, the center of your filter should basically align properly with any pixel. What I mean by that is, let's say this is our pixel, right? The central pixel of your filter. So can we apply this filter by keeping the center of this filter over here? No. Why? Because in order to apply this filter, we need a 3 cross 3 matrix in the surrounding area. But in the moment we apply on this, this is how the filter is going to look like. Right? So this is again 3 cross 3, you can say, but then this is a 3 cross 3 filter, which is nothing but this filter. But then we can't apply this filter on this particular pixel position. Why? Because these are the pixel value we need in order to apply this filter, which are not available. Okay. So first we'll have to see where exactly can we apply. Okay. Okay. So first we'll have to, this is where we can apply this filter. Okay. Because here we have, the moment we place the center of this kernel, over here we have a 3 cross 3 matrix in the surrounding area, right? So how we apply any filter? There are multiple ways, but then the way which we are going to discuss is, let's say the moment we place this filter on this, this is how the values are going to look like: 0, 0, 0, 0, 1, 0, 0, and 0. What are these values? Nothing but the filter values, right? And then we are supposed to multiply all these, the original image pixel value with the filter pixel value, right? So that's going to be 0 into 0. This is going to be 1 into 0. This is going to be 2 into 0. This one is going to be, okay, let me change the color. This is going to be 2 into 1, 1 into 0, 0 into 0, 0 into 0, 1 into 0, and 2 into 0. Now again, if you see, so we are going to get 9 values. There are multiple ways by which you can combine them. One is called, you can either take sum of it, or basically you can take an average of it, right? So let's say if we take only sum of all these values, so the only value which is going to be, which is non-zero, is this 2 into 1. Everything else is going to be nothing but 0, right? So this is what we see. Once we apply this filter on this particular position, the value of this position is going to be 2, right? Because 0 into 0, 0, all these values are going to be 0. Only non-zero value is this one. So if you take a summation of all these values, this is going to be 2, right? So the new value at this position is going to be 2, right? So this is how we apply any filter. Now, the moment we apply any filter, and this process of applying the filter is also known as convolution. So there are other two parameters which we'll have to understand. The next thing is we call it stride. What is stride? Now, if you see, this is the first position where we have applied any filter, right? So what's a stride? By how much we need to slide this filter, right? Now, if you notice, we can slide this filter in two directions, horizontal direction and the vertical direction. Now, the amount by which we can slide this filter, okay, is known as stride. So let's say if we have a stride of 1 in the horizontal direction. So what is going to be the new position of this filter? Nothing but you can say this. Okay. But then let's say in any different architecture, if we have, yeah, we have stride equal to 2, then what is going to be the value of new filter in vertical direction? This is what is going to be the position of your next filter. Clearly you can see that we took two steps in the vertical direction in order to apply my filter, right? And here the direction is nothing but you can say 1, as the stride is 1, so we have also taken one step, right? So this is what is called as stride. So what is a filter? Filter is nothing but we also call as kernel or a mask, okay? And what is this convolution process? Convolution is a process where we apply one function on a second function in order to get the third function. So, and what is a stride? Amount by which we slide our filters, okay? That is known as stride in any convolutional operation, right? So once we apply this filter using convolution, call it mask or kernel on this, this is what we will get, right? So this is going to be your new image features, okay? Now, one advantage of this is, now in real life, the data set which we get when it comes to image or you can say video are going to be very high dimensional in nature, right? So what happens is the moment we try to train a model on the raw image, the vectors are going to be very high dimensional, and all the calculations are going to be very computationally very you can say that is going to be very computationally expensive, right? So now what happens if you see the moment we apply the convolution process, okay, we are in a way trying to reduce the dimension of our image, right? So this is also going to be helpful when it comes to making your system computationally efficient, right? Right. There are different kind of filters which we use when it comes to convolution operation. At the same time, there are multiple filters which we can apply in a single layer on the input image, right? Yeah. Like if you try to notice what exactly we do using this filter, right? So it's nothing but in like if you are aware about any image editor software, right? We have move left, we have operations like move right or erase, or you can say rotate, right? So this is one filter which is nothing but move everything towards left, right? As you like, if you notice, the moment we apply this filter on this particular input image with a stride equal to 1, all the pixels are in a way migrating towards left, right? So clearly you can say 2, 3, 4, 5, right? So all the pixels are basically going to move towards left, right? And also you can see that we started with a 6x6 filter, but then after applying this filter, the size of the new you can say images or the feature or the matrix is 4x4. Why the size 4x4? Because if you see with stride equal to 1, this is what is going to be the first position of your filter, okay? Similarly, this is going to be the second position of your filter. Then again, after applying one more stride, the third position, and last but not the least, this is going to be the fourth one, right? we can't basically move this filter in horizontal direction after 4 strikes, right? So how many values we are going to get in the horizontal direction? 4. Similarly, in the vertical direction also, if you see the first one, the second one, the third one, and the fourth one, right? So even in the vertical direction, it's going to be 4. Yeah. So that's about the filters. I'll move to the next slide. If you see again, this is nothing but, again, let's say you can call this as input image. Let's say this is your input image and this is the filter. Okay, and this is the output image. Once we apply this filter on this, this is nothing but, this filter is nothing but, you can say, edge detection filter. Okay, why this is edge detection filter? Because if you'll try to understand what exactly is an edge, right? So we call it any sudden change in the intensity of an image or the color is known as edge, right? Like, for example, if we need to identify edge in this image, where exactly we have the edge, this is where what we can call as edge, right? Why this is an edge? Because here we see certain change in the intensity, right? So as I have said in the beginning, 0 on a grayscale image is nothing but black and 255 is nothing but white. So let's say if this image is for a grayscale image, in real life this image is going to look like this. Okay, the first part is going to be completely black. See, this part is going to be completely black. Okay, and the second part is going to be white, right? So where is the edge? This is where we are going to have our edge, right? In the center of the image, right? So once you apply this filter, you will get something like this. So clearly you can see that the two parts are going to be black and we are going to have some center, we are going to have some white line in the center. So this image is nothing but something like this. This is how this image is going to look like. These part as black, and we are going to have this white in the middle, which is nothing but our edge, right? So this is again one, this is nothing but convolution. We applied one filter on the input image and we got an output image, right? Yeah, yeah. So this is, but then this filter is known as edge filter. Okay, now if we move to next slide and the next concept, that's called as max pooling. So first of all, we'll have to understand what exactly is a pooling, right? So now what happens is, yeah, pooling is nothing but again where you apply some filters, okay? You can say on a particular image, but then in this case, the way we transform the input matrix, once we apply the filter, we just extract the maximum value out of that filter, and that maximum value is going to be the new value of our, you can say, third function or the output matrix, right? So let's say if this is, we are trying to apply, again, this is what? This is nothing but a kernel or a filter, which is 2 cross 2. And if we are trying to apply this on this, this is how it's going to look like. Okay. Now, what is the maximum value? What is the maximum value over here? 1, right? And let's say if we are applying this pooling with stride equal to 2. So the next value is going to be, the next position of our filter is going to be this. Now in this, if this is your first, this is your second, what is the maximum value? 3, right? So the next value in our output image is going to be 3. Then this is nothing but the final position of our filter, third one. And what is the maximum value? 5, right? So the 5. And again we can apply this in the vertical direction and we'll get 1, 1, then 3, 3, 5, and 5. So once we apply this filter on this is what is going to be the output. So what's max pooling? Once you apply any filter, the new value of your output matrix is going to be the maximum value in that filter. Okay, like the maximum value, once we, this is the position of our filter, is 1. In this, the maximum value is 3. In this, the maximum value is 5, right? So again, what is max pooling? Nothing but a convolution operation. In this also we apply a filter, but then the difference is the way we derive our output matrix is that we pick the maximum value out of any, you can say, your filter position, right? So this is what is known as max pooling. Now what happens if you'll try to understand the intuition behind max pooling? Let me tell you something about all these data science projects or machine learning project, or let's say AI project, right? These are very much exploratory in nature. At the same time, they are very much iterative in nature, right? So what happens is, like, empirically, you can say the AI engineers or the AI researchers, they have found that these max pooling are in a way very helpful in capturing the feature out of your image. At the same time, they make all the computation very efficient, right? So still there is no mathematical, you can say, uh, logic, or you can say a concrete mathematical reasoning behind applying max pooling. But then empirically, in most of the successful architecture we have around us, max pooling is performing very well than any other filter. Okay, yeah. So that's about max pooling, right? So let me very quickly summarize whatever we have discussed till now. We discussed what is a neural network, what is computer vision, and what exactly is this CNN. So CNN is nothing but an you can say a different architecture or a variant of neural network, right? When it comes to convolutional neural network, there are multiple important components like filter, which is nothing but, you can say, an n cross n matrix which we apply on any input image in order to extract the feature out of it. Then we have this concept of, you can say, pooling, where again we apply a filter but then we extract the max value. We have different kind of, you can say, pooling, like average pooling. At the same time, we discussed about strides. Okay, what's in a stride? So the amount by which we slide our filters in horizontal and vertical direction, that is known as stride, right? So now let's try to jump into one, you can say, uh, pseudo architecture for, let's say, one of the classifier that we are trying to build, right? Yeah. So let's say we are trying to build one animal classifier, okay? And let's say we have an image, input image of size 28 cross 28 cross 1. Cross 1 means this image is going to be on a gray scale, right? Okay. And 28 cross 28 is nothing but, let's say, 28, 28. And as this is one animal classifier, clearly you can see that we have 10 units, means we are trying to classify, or the total number of labels we have in our output is 10, like cat, dog, elephant, zebra, a deer, let's say a rhinoceros. Okay, then maybe you can say 1, 2, 3, 4, 5, 6. Yeah, something like a lion, maybe a leopard, and then a tiger and monkey, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say if we are trying to build a model which can identify these many different animals. Okay, so what exactly is an animal classifier? If this is one image, and let's say we have cat in this image, so any neural network, or you can say CNN trained model, input is going to be this image, which is, let's say, input image. Okay, and output is going to be cat, right? So this is what we are trying to build over here, right? So how we design an architecture? Clearly you can see that, let's say if we have an input image, let's say we have a convolution layer where we basically use 32 filters. And what's the size of all these filters? 3 cross 3. So this is how it's going to look like. This is one filter, the second filter, the third filter, the fourth filter. And how many such filters you're going to have? 32 such filters, right? And what's the size of each filter? 32 cross, sorry, 3 cross 3. You can say 3 cross 3. And once we have applied convolution, what we do? We are applying a max pooling. And what is the size of filter over there? This is what is the size of filter, or you can say pooling, 2 cross 2, right? So this is what is going to be known as. So if you guys remember, like this is how we represent any neural network architecture, right? So how many layers we have here? Three. One, 2 and 3, right? So in this particular component is going to be known as, you can say, your first layer or one layer, right? Similarly, whatever is going to be the output of this is going to be input to the second layer. So this is what is known as your, in this architecture we can say this is our second layer, right? And this is nothing but our third layer, right? Okay. So like in this architecture where we are trying to build one animal classifier, we have three, you can say, hidden layers with, in the first layer, we have convolution 32 cross 32. Again, in the second, 32 cross 32, 32 cross 32, and we have a max pooling layer, right? And once we apply these three, we have an output, which is gonna like, after this third layer, we are gonna apply the flatten process. So what is a flatten process? Nothing but you can say that, let's say if 3 cross 3 is your metric size after your final layer, or you can say this layer, right? So once you apply your filter, you convert this 2D into like this 1 cross n matrix, which is how many pixels we have in this image? 9. Okay, so 1 2 3 4 5 6 7 8 9, right? So you can say one row and 9 columns, right? So what's going to be the size? 1 cross 9. Okay. So this is what is called as flatten, again in any CNN architecture. And after that, we have a dense layer in which 128 units are going to be there. So what is a dense layer? So how many neurons we are going to have in this layer? 128. 1 2 3, you can say till 128. And what we mean by dense layer, that let's say if we have 9 neurons in the immediate layer, or you can say a layer just like before that, dense means all these neurons are going to be get connected to, are going to be connected to all the neurons in the next immediate layer, right? So this is what we mean by dense layer. Okay, and once you have this, so this is the first layer, second layer, third layer kind of process. This is the fourth layer, and finally we are going to have our output layer. In output layer, what are we going to have? We are going to have how many neurons? 10 neurons. Why? Each neuron, you're going to have one neuron for each of these classes. So how many classes we have? 10. So 1 2 3 4 5 6 7 8 9 and 10. So let's say after these 128 layers or neurons are going to be connected to these 10 output neurons, and finally we're going to have, let's say, probability distributed across 10 different classes. Like if let's say input is, the input image consists of dog, right? We have dog in the input image. And let's say the third neuron is what is for D, means you're going to have very high probability over here, let's say 0.5 or zero 0.6, and everywhere else it's going to be 0.1, or let's say very you can say 0.025, 0.025. This is nothing but a probability distribution. So all these values are gonna basically add up to 1. So make it 0.05, 0.05, and again 0.25, 0.25. So this is gonna be as 1, 6, 7, 8. Yeah, and then you can say zero point 0.1, zero point 0.1, right? So this is how we design any architecture for, you can say, a CNN network, or you can say any like when it comes to computer vision, when it comes to applying any CNN model, this is how we'll have to design the architecture. So it's going to have some input layers, some convolutional operations, some max pooling operation, then finally a flatten layer, then a dense layer, and then finally your output layers, right? Now what happens if you see, right? If we'll try to understand uh, the trend in the deep learning environment, right? Recently we have seen like let's say advancement in all these architecture, and when it comes to deep learning you'll need a very huge data set, right? And at the same time the architectures are going to be very deep when it comes to the number of layers, and that's the main reason these are called as deep neural network or deep learning, right? So training your own model is going to be very you can say time consuming. At the same time computationally it's going to be very expensive, right? So I'm going to discuss about, very briefly I'll touch upon the transfer learning and the recent advancement, but then even before that let me just discuss the concept of object detection in the next slide. So let's say this is what we have. This is one architecture or a CNN model which, let's say, we have built for an animal classifier. Let's see how we can actually use this in order to make an object detector. Okay. Yeah, let's say this is one image, right? Now what exactly is object detection in this context? We say that animal identifier is nothing but our in this particular context, by object we mean animal, right? So how many animals we have in this? Sorry, how many animals we have in this? We have, you can say, around 4 to 5 different animals. So once you apply this model, or once you apply this image to any of the you can say object detector model, this is how it's going to look like. So it's going to form multiple bounding boxes around each and every animal. Okay, here we see one animal over here, one animal over here, and then maybe one over here, right? But actually we have two, but then again assume that the model is not 100% correct, right? So once this image is going to be input to any object detector, this is how the output is gonna look like. Why? Because in this we have four animals, right? And again, by object we mean in this context it's only animal, right? So how exactly we can use the classifier which we, let's say, or the model which we discussed in the previous slide, right? Like if you try to understand on this image, once we apply our the model which we discussed in the last slide, the output is going to be, okay, we have, let's say, some animal in this, okay, which is rhinoceros in this case, right? But then where exactly, what is object detection? In object detection you just don't need to identify that, okay, in this image we have some animal. We'll have to identify the position of that particular animal or object of interest, right? So we'll have to actually, these are called bounding boxes. Okay, so these are all called bounding boxes, right? So what we are supposed to do, we'll have to not only identify if this image uh, carries any animal or not, but then you will have to exactly identify the coordinates or the position of animal in this image. So how we can use the classifier we discussed in the previous slide. So what we can do is, we can basically, if you guys remember, let's say the model which we have developed is for 28 cross 28 cross 1, right? So what we can do is we can divide this entire image into multiple grids, right? Like this is 1, 2nd, 3rd, 4th, 5th grid, 6th, 7th, 8th, 9th, and 10th, 11th, 12th. 13th, 14th, 15th, 16, 17, 18, 19, 20. Now what's going to happen? All these images, like this particular grid is going to be input to our model first. Okay, let's say our CNN model. And the output is going to be if this particular grid comes with an animal or not. So let's say no. For this one, no. For this one, no. So what we are doing, all these individual grids we are passing on to a model, right? So this is also going to be no, no. We are going to have yes only for these grids, you can say. So what we are going to do is we are going to say, okay, hey, as this grid is something where my model says that we have some animal, so let's draw a bounding box over here, and then a bounding box over here, and a bounding box over here, right? So this is how we can use the model discussed in the last slide to build one object detector, right? But then yes, of course, there are more smarter ways, or you can say there are more intelligent algorithm which helps you in doing object detection. This is just one of the simplest way. Okay. Now, let me summarize what we discussed in this entire webinar. So we discussed what is computer vision, nothing but whatever we see around us. Okay, the pictorial representation of any entity or event is what is called as vision, right? Then we discussed the different applications of computer vision, be it image captioning, video surveillance, object detector, image search, and then the main algorithm which empowers all this model is known as CNN, which is also called as convolutional neural network. And the main reason behind name neural network is that all these algorithms are actually inspired by our human brains, right? And in our human brain, we have millions of neurons, which in a way communicate among each other in order to perform a certain or a specific task, right? So when it comes to CNN, there are multiple building blocks like max pooling or filter or stride or the convolution process. So once we do that, we can design any architecture which can basically help you in building multiple, you can say, image related models, right? And we discussed that how this architecture, like this can be one architecture which you can say for an animal classifier, and we can use this animal classifier for any object detection task, right? But then let me discuss about the recent advancement. We have multiple, you can say, advancement in CNN architecture for object detection. At the same time, when it comes to deep learning, data is very much important, right? You need a huge amount of data in order to train a deep neural network, right? So what happens is it's going to be very difficult for you to kind of train a model from scratch, right? So what happens, all these big organizations like you can say, or research organizations like Google or Google Brain or Amazon or Apple, they train all these, you can say, deep neural network architecture. And what you do is basically you try to carry, or you try to use some information from these pre-trained models, right? So there is one concept called transfer learning in deep learning which we use in order to basically exploit or utilize some information from already trained model, or you can say pre-trained model, right? And when it comes to object detection, again, we just discussed one of the simplest way of doing object detection, but then there are an efficient ways of doing object detection. So what we're going to do is in the follow-up, you can say webinars, first we are going to we're going to have more practical examples where we'll do some hand, you can say, train some neural network architecture. And at the same time, in for, you can say, follow webinars, we'll discuss other concepts like transfer learning and object detection using yellow algorithm. Yeah, so that's it from my side on this webinar. Again, once again, I'll request all of you to basically subscribe to our channel, because once you subscribe, it's going to be very easy for you. The moment we release any webinar or any interesting topic, you're going to be notified with that, and you can clearly come to the YouTube on our channel and you can watch all these contents. Thanks a lot, everyone. That's it from my side. Good night.